have another amazing opportunity here for you. You will be hearing from Amit Sangani from Meta, who is responsible for the launch of Llama 3 that just happened last week. Hopefully you all are familiar and aware of what LLMs are and what Llama and Llama 3 is all about. Amit is the Director of Partner Engineering, leading the AI developer-facing engineering teams, working and leading on Gen AI, making Gen AI, democratizing it for developers to use it in their products and ensure that we are improving productivity and enhancing our ability to achieve better capabilities with generative AI. Prior to being at Meta, he spent several years at Google and Android, and will be sharing information about Llama 3 and giving a hands-on workshop to all of you on how you can quickly stand up chatbots and get productivity in your teams. Without further ado, I will invite Amit Sangani to the stage. Thank you.
Good. It's really hard to follow Jensen, and it was really nerve-wracking to get this spot. But I'll try my best to do justice for your time. So my name is Amit Sangani. I am Director of Partner Engineering at Meta. I've been at Meta for 9 years. And this animated GIF which you see is generated by Llama. So I'm going to talk about Llama. With a show of hands, how many people have used Llama? Okay, about 20%. So I'm pretty sure you'll learn a lot after this session. My goal is to teach you everything about Llama, teach you everything about Meta AI, and hopefully you'll be more informed after this session. So I'm going to go through Meta AI. We launched Meta AI and Prompt and Llama just last week. And so this is one of the early shows of Llama, literally, at a big presentation. I'm also going to go through the prompt engineering. Prompt engineering, as you guys know, is becoming really popular among a lot of the AI and Gen AI engineering world. And by the end of this session, you'll know the basic concepts of prompt engineering. And I'm actually going to go through the code as well. So for people who are familiar with code, they should easily be able to get it. But if people are not familiar, don't worry. You will still be able to get it, I promise. Okay, so let's start with Meta AI. Now, how many people have actually used Meta AI? Okay, I do see some hands here. Okay, very few people. Okay, so what I want to do is check out meta.ai. Now, how many people have used ChatGPT? Okay, it's almost 100%. So meta.ai is similar to ChatGPT. We just launched this last week, and you can ask any question, just like any large language model. You can send a prompt, and it will respond. So here on the right-hand side, you see some code. It can generate code as well. Okay, and I have a small demo as well, which you can see here, if the video starts. Yeah. So here, I don't know whether you can see, but it is very small. You can type in, plan my trip to New York, and it will basically plan your trip. And you can see the inferencing speed. It's pretty fast. And not only that, you can generate images on the fly. So I've typed in imagine at the bottom, and I'm typing in, draw a nice picture of a dog. And as you type, it generates the image. And I'm going to type in a picture of a dog, which is a Labradoodle, because I have a pet, which is a Labradoodle. So I'm going to ask it to draw Labradoodle. And my dog is white in color. So I'm going to ask him, like, hey, a white one. And then I asked, like, put it in front of a house. I generated this picture. And you can select any of these pictures, save it, and use it. And this is on the fly. So you can use it right now on your browser, meta.ai. All you need is one of the Facebook accounts. That's it. And you should be able to use this. So next time when I come here, I want to see 100% of the hands up. OK, so hopefully that was cool. But not only this, we haven't made meta.ai available only on the browser. We have made it available on all our family of apps. So here you see the integration within WhatsApp. So on WhatsApp, you can ask any question to meta.ai, and it creates a new thread. And now you can start communicating with meta.ai. So in January, I was in India. I was traveling all over the northern part of India. And I was using this as my assistant to answer any question I have about Taj Mahal, about Vrindavan, and so forth. And here's the query where basically I put in Paris 2024. It goes and gets me that information right here within my app. And not only WhatsApp, it's integrated inside Facebook search, Instagram search, and Messenger search. Okay, so you can enable this today. It's all available right now. But what is this powered by? It's all behind the scenes powered by a large language model called Llama. And so we are going to talk about Llama. We launched Llama 3 last week. It's one of the most performant open models, now available in two sizes, 8 billion parameter and 70 billion parameters. Here's a brief timeline of our models. We launched last year in July, Llama 2 and Code Llama. And the difference between Llama 2 and Code Llama is a fine-tuned version of Llama 2, which is mainly used for coding purposes. So it can generate code, it can analyze code, it can debug code. We have now over 170 million downloads of Llama models, nearly 50,000 derivatives of Llama models on Hugging Face, and 12,000 projects. These are generative AI projects in production. We also launch trust and safety. These models are very powerful, and it can do good things, but it can do bad things as well. So we wanted to make sure that these models are used responsibly out there. And so we came up with a trust and safety solutions where once you fine-tune your model or you're using it in Gen AI application, you can run your tests to make sure it is trusted and it's safe for your users. We launched trust and safety adoption, which was adopted by all the major players like Amazon, Databricks, and it's on their cloud-hosted environment. Then we launched Code Llama, 70 billion parameter. Now, just so that people know, the smaller size models, 7 billion parameters and 70 billion parameters are different in terms of the size, in terms of the amount of information you can stuff in there. Think about neurons in human brain. The less the number of neurons, the lesser the intelligence is. Same thing with these billion parameters. The higher the billion parameter models are, the better it is in terms of logical reasoning, in terms of the output and accuracy you can get from these models. OK, so we just launched Llama 3 last year. And the great thing about these models are it's completely free. It's allowed for commercial use. You can download these models, play around with it, use it in your Gen AI applications at no licensing fees to Meta or any other party. So if you haven't used it, I would highly encourage you to play around with it. And as a starter code, we are going to use it today, and I'm going to show you how to use it as well. Just a little bit about what is the difference between Llama 3 and Llama 2. Llama 3 is way more powerful. It has 7x more data. So you train these models, foundational models with data. You must have heard about context length. This is the input you can send it to your models. And so it has 8,000 context length of 8K tokens. And think about tokens as the number of words. Now, it's not exactly a number of words, but think about it as words. So you can send 8,000 words at the same time. It has over 10 million human annotations. What that means is we have trained these models, fine-tuned these models with human intervention. We have made sure that humans really understand the output and then correct it and again retrain these models. And these are state-of-the-art models, one of the most high-performing models. And there's benchmarking, industry benchmarking, which we do against these models, or against reasoning, coding, proficiency, and knowledge tests. And so here's what we did. So Llama is from Google. Mistral is another open source models. And Meta Llama 3 outperforms all of these models out there on the left. And then on the right, Gemini and Claude. The 70 billion parameter model still outperforms them. These are industry benchmarks we do. So what's next? Our 400 billion parameter model is right now in training. And we are highly optimistic that we are going to close the gap between ChatGPT and Llama. And these models are training, but the 400 billion parameter model already is beating the benchmark of 70 billion parameter model on Llama 3. And we still have a few months of training left on these models. So we are super excited about this coming out later this year. So now I'm going to go through the code. And again, like I said, if you've never done coding, don't worry about it. You'll see it. You'll really enjoy it. Because I'm going to do some comparison. I'm going to do prompt engineering, coding in Python, in a Google Colab notebook. And you will be able to follow through the code, hopefully. And here's the treat. So people who are interested after this session, please take the QR code or this URL. You will be able to get $100 credit directly from Replicate. Now, this is different than AWS and so forth. Your $100 credit can go a long way, actually, for you to help learning and so forth with Llama, or any other models, actually. OK, so now let's go to the code. I'm going to switch my screen. I have it here. And I'm going to connect here. Now, I want to make sure, because I'm tethering from my phone, so it might be interesting if it works. Yes, it did work. OK, cool. So let me go full screen here. And let me show what this is. So this is Google Colab Notebook. What we are going to go through today in our session is a bunch of things. I'll show you what Llama is, how many what are parameters, which we already talked about. How do you access Llama? There are different ways you can access Llama models, and I'll show that. I'll show a comparison between Llama 2 and Llama 3 by actually calling these models on our server. Okay. Then I'll show you how to build a chatbot. What I'm going to show you is the fundamental basics of a chatbot, and why it's so important to learn that, because most of the Gen AI applications are chatbot related. Then I'll give you the basic concepts of prompt engineering, fine-tuning, and then conclude with some resources which you can take it and then learn more about Llama. OK? All right. So what you see here is a Google Colab notebook. There's a runtime environment which I've selected. As you all know, and as Jensen said, that GPUs are critical to Gen AI development. What I'm going to run today is just on a CPU. Okay, but if you're fine-tuning a model, if you have a large workload, which you are going to inference against, then you have to use one of these GPUs. Okay, so I can use this. These are on the server on Google Cloud. I can use them, so forth. So that's pretty much it. And then all my code is in Python, okay? And it's a really short code, so you'll understand it. Okay, I'm going to run this basic cell. This is a UI generation for cell. So it has JavaScript code, so I won't worry about it. What is Llama 3? We talked about it. It has 8 billion parameter model. Now there's a base model and there's an instruct model. So what is the difference? The base model is the foundational model. We take all the publicly available data set, including Wikipedia, Stack Overflow, everything you can think about on the internet. We take that and train our model. And these are foundational models, what we call it as. If you have a specific purpose where you want to build a GenAI application for healthcare or commerce or something else, you want to take the foundational base model and then fine-tune it with your own data set. Okay? The instruct model is mainly geared for dialogue use cases. So customer service chatbot, you want to use an instruct model because it is like an assistant who is going to give you responses. You can access these models across multiple different avenues. One is you can download directly from Llama's website. And these are large models, so you can run it on your machine, but it's going to be very slow. You ideally want a powerful GPU or a CPU on the server to run it. You can also use one of the hosted API platforms. So today, I'm going to use Replicate, and like I showed in the other slide, you get $100 credit for that. But you can also use Together Anyscale, or there are a bunch of other providers. And it is also hosted on all the major cloud platforms like Azure, AWS, and GCP. We have partnered with all these partners, and our models are available there. So you can, with few clicks, you can start using them as well. I won't go into too much details around the use cases, but most of you know it is mainly used for content generation, summarization, chatbots, RAG, retrieval augmented generation, and we'll go through this. This is a very important concept in prompt engineering now, where people want to append the latest data inside the model. So the model becomes more aware about what is happening now instead of when it was cut off. The data was cut off to train the model. And fine-tuning, and then agents. Agentic workflow is really becoming important, and it's becoming the next big thing in the GenAI space. Okay, so now I'm going to start coding. So the first thing you would do is install Replicate. So this is a way to install a package so that I can use Replicate APIs to call. The models are hosted on Replicate server, okay, on the cloud. And so to use that APIs, I have to install a package. And so this is what I'm doing. I'm running this in real time. Because there's no Wi-Fi, I'm using my phone to tether it, so it might be slow, but it's looking really good. Then I have to install the Replicate token. So this makes sure that Replicate server knows that these requests are coming from me. So every request has a token which is sent. And I've already entered my token here. Now, there are 3 functions. One is for Llama 2, one is for Llama 3 8B, and one is for Llama 3 70B. All these functions are doing is basically calling the right models on the server. Okay? So when I call Llama 2 later in the code, it's going to call Llama 2 7B chat model. And what you see here is the prompt, which I will send in, and then some of the hyperparameters, what we call it as. And I will explain this in a little bit more detail, but the tokens is something which I told you about. The words are the number of tokens. I'm going to limit it to 2,000 tokens so that the speed is fast for us to communicate. And so I have this for Llama 2, 7B, Llama 3, 8 billion parameter. And the reason why I have these 3 functions is I want to compare between Llama 2 and Llama 3 and the power of Llama 3 and how good it is. Okay? Okay, so now I'm going to make the first call. Here's my prompt. The typical color of llama is. Now, as you know, llama is an animal. And so I'm going to ask the model, what is the typical color of llama? And I'm going to run this. And this is coming from the server. Can people see this, right? Or do I want, yeah? Can people see at the back, see this code? Yeah? OK. I can increase the size as well a little bit. Maybe I can close this. OK. So as you can see, it responded back. Typical color of llama is not factual or coherent question. Doesn't look like, it's pretty chatty, right? And so ideally, I want a clear one-sentence response. So llama 3, 8 billion parameter says typical color of llama is white, but it could be in different colors as well, light brown and so forth. So as you can see, Llama 3 is not as chatty as Llama 2. Okay, so let's move forward. Now, we talked about temperature. Now, these large language models are based on an architecture called transformer architecture. It uses autoregressive decoding models, architecture. And what essentially it is doing is it is always just predicting the next token. Okay? And you can control the variety you get from these models by setting the temperature. So if you set the temperature to 0, it is deterministic. What that means is you're going to get exactly the same output every time you call. So when I call Llama 3.8b with temperature 0, you can see it is sending me something. Now if I call it again, it's giving me the exact same text. Okay? Which is pretty cool. But what if I want some variety in my output, right? Then I set the temperature anywhere from 0 to 1 scale. I can set it to 1, and it will give me, different answer every time I run. So every time I run this, it's going to be a different answer. So this one is different, this one is different. And sometimes it's fun to chat with the model as well, because you get interesting answers as well. Okay, so now you know the basics of how to call the models. Let's talk about what it takes to build a chatbot. What you see here is the basic architecture for all chatbots. There's a user who sends in a prompt, and prompt is basically what they type in to the LLM to respond. It goes through a safety layer. Now you can add an additional safety layer before it goes to the model, or the model itself has a certain level of safety. Then that context is sent to Llama 3. Llama 3 generates the output. It goes again through an output safety layer. And this is important because you want to make sure that the output you generate through the model before it's sent to the user is going through the safety layers for compliance reasons and so forth. And then it goes to the user. But as you know, HTTPS is stateless. LLMs are also stateless. So every request you send it, it doesn't store that information. It just generates your response and then gives it back to the user. To build a chatbot, you have to store the context. And to store the context, you have an extra layer or extra component called memory. And that's where you store the memory. So you have to store the history. So if I'm buying something on an e-commerce site and I'm chatting with a chatbot, an assistant, then it needs to know what my previous conversations are to give me an intelligent response. So that's how this memory is used. And for every input, it is sent as part of the context back to the model. So this is like really the bare bones architecture of a customer service chatbot. So let's look at how this is coded. And let's run this using code. So I'm asking a question, what is the average lifespan of a llama? Answer the question in few words. And it basically answers average lifespan of a llama is around 15 to 20 years, which is good. Now I ask the Llama 3 model, what is the same question? And it says 15 to 20 years, which is still, as you can see, Llama 3 is way more precise and consistent in the answers. Now, my follow-up question is, what animal family are they? Answer the question in few words. Now, do you think Llama will be able to understand this? Most likely no, right? Because it doesn't understand what day is, right? So if I run this, it says, sure, I would be happy to help. The animal family that the question is referring is carnivora, which is not right. And so it is hallucinated. So for us to tell the model what is they, we have to send the previous context. And to do that, here's the multi-turn chat, what we call it as multi-turn chat. Multi-turn chat means you're storing previous conversations in memory and then sending it as part of every next request. So here I'm asking, user is basically a user, and assistant is the response coming back from the model. And here's the format. What is the average lifespan of a llama? 15 to 20 years. What animal family are they? Now it has the context of what they is, and then is able to answer the question correctly. Now this is super important. I mean, this is a really bare bones, simple example, but this is the concept behind chatbots. And this is all automated, so you don't have to keep on stuffing this in your prompt. You can have an object which stores this, or a list which stores this history and be able to respond back. All right. So, so now Llama 3, 8 billion parameter model is saying llamas are members of camelidae family, which includes camels, alpacas, which is a right answer. We can also instruct the model to answer in a single word. Okay? Now, as you can see here, Llama 2 doesn't do a good job. It basically still gives you a sentence. But Llama 3 actually respects what is there by the user and then exactly sends camelidae. Okay, are you guys with me? Yeah? Okay, cool. Okay, so now let's look at prompt engineering and what is this. So I'm going to explain the basic concepts. So whenever somebody says prompt engineering, you guys know exactly what he's talking about, okay? At least after this session, you would know that. So there are a few concepts in prompt engineering. One is in-context learning. And what that is means, as part of your prompt, sometimes you have to give examples for LLM to understand what you are asking for. And if it's few shot, that means you are giving few examples. If it's zero shot, that means there are no examples. Okay? So prompt engineering is an art more than perfect science. You have to play around with your prompts to be able to get the right response. So we start with the simple zero-shot learning, where I don't give any example. I just say, hey, classify this sentence, I saw a gecko. And then I put a question mark. So I expect the model to answer the question. And when I run this, okay, it will basically give me a sentiment. Now, typical sentiment is positive, negative, or neutral. Okay, that is what I'm expecting. But it's saying interesting. Now, I don't blame the model. If you ask somebody, like if you tell somebody, like, I saw a gecko, I don't know what kind of response they are going to give. Probably saying interesting, right? But what if we want a particular response from the model? So then you basically give some examples. Like, look, I love llamas. Sentiment should be positive. I don't like snakes. It should be negative. And now you ask the same question, and you ask the model to give answer in one word. And again, our Llama 2 doesn't do a good job, but at least it probably should get the right sentiment. But it didn't answer in one word, right? And Llama 3 model does answer in single word, which is neutral. So this is the basic concept of zero-shot learning and few-shot learning. And this is called in-context learning, the whole science. And it is way more complicated than what I can show in 45 minutes, but you get the idea. Okay. I'm going to skip some examples in lieu of time. I want to explain another very important concept in prompt engineering called chain of thought. As you may have heard, LLMs don't do a good job of solving problems. They are not like calculators, okay? Because of the architecture in which they are built, okay? They are just predicting the next token. Now, you can still train your model, or you can still prompt your model to give you an accurate answer. So let's see how this happens. So I give a simple word problem, and you can see it here. Llama started with 5 tennis balls. It buys 2 more cans of tennis balls. Each can has 3 tennis balls, so 2 multiplied by 3 is 6, plus 5 is 11. How many tennis balls does Llama have? And I asked the model to answer in one word. I don't want that chattiness, okay? And when I run this, let's see what answer I get, 17, which is wrong, right? So you can imagine, like, it can write a poem, it can rhyme things, it can write a, actually a script of a movie, but it cannot solve a simple problem like this, which is weird. Now, Llama 70B model is able to get the right answer, which is 11. And the reason it is because it has more information, it is good for logical reasoning, it can understand step-by-step calculation, and then give the right answer. Okay, so this is where the difference is. The smaller models are faster, cheaper to run. Larger models are more accurate, but more expensive to run. So depending on your application, you'll have to run this trade-off to select the right models. But now, if I ask the model, the 3 billion parameter model, I remove the word answer in one word, okay? And then I ask the model gets time to think through it. And by default, it will break down the problem step by step. Okay? So our 8 billion parameter model is actually able to do the same thing what a 70 billion parameter model is doing. Now, this is a really important concept. What this tells you that you don't have to necessarily always use the larger models. You can use a smaller model, but do prompt engineering to get the desired response. And you can save the cost, you can still get the accuracy by doing prompt engineering. So this is the value of prompt engineering. Again, this is a super simple example. There are very complex examples of these kind of stuff. But I wanted to at least portray the hypothesis of why this is the way it works. Okay, I'm going to skip a few things. I have another example of who lived longer, Newton or Einstein, which is pretty interesting that these models don't get it. But what they get it is like, hey, Newton lived from 1643 to 1727. Einstein lived from this and this years. And Einstein living 128 years, which is wrong. Again, it has hallucinated, right? Wrong information to the user. But our 8 billion parameter model fails. Our 70 billion parameter model is actually able to give the right answer. Now, if I change this model, let's say, let's see what happens here. Nope, still didn't work. Okay, because I have maximized my context lens to 2,000 tokens, it broke here. But now it is able to calculate a bunch of things, which looks like pretty accurate. From 84 to 76, it would have given 84 years minus 76, which is 8 years. Okay. All right, so there's another concept called knowledge prompting. Now, what do you think is the answer for this one? Okay, maybe I should clear the outputs. The part of the golf is trying to get a higher point total than others. How many people are golf players here? 2, 3, 4, 5? Okay, handful. Okay, but people probably watch golf as well, right? What do you think is the answer for this one? No, that's right. However, our model says yes. Because it's trained on typical sports where higher points is a winner, right? Now, when we say explain your answer, now it says I would answer no, and here's the reason why. So again, I'm trying to prove the same concept that doing prompt engineering allows you to get a better desired output from your models. Okay? Okay, I'm going to skip through a bunch of things since we are almost getting past my schedule. Okay, so retrieval augmented generation. So prompt engineering is good, but it has limitations. How much can you really massage the incoming prompt? And there is one fundamental flaw as well. LLMs are trained until a cutoff date. And once they are launched, they don't know anything after that. So our Llama models were trained until February of 2024. Anything after that, it doesn't know. So how do you get the latest information? There is a concept called retrieval augmented generation, which allows you to augment the latest data with the LLMs. And here's how it works. Okay? So here's a simple example. Who won the World Cup, 2023 Women's World Cup? We are asking to Llama 2 model. It won't have that information because the cutoff date was before 2023. Okay? So it basically hallucinates. However, I must inform, blah, blah, blah. It hasn't taken place, which is false, obviously. It has taken place. And there was a country which won that. And so, but our 8B model also hallucinates. It says United States actually won the Women's World Cup in 2023. This is false. The reason why it said that is because United States women's soccer team is really good, and they have won most of the World Cups, as far as I know. So it just took that data and actually used it. The real answer is given by 70B model, which is the Women's World Cup was won by Spain. But the reason why it was able to do it is because the cutoff date is February of 2024 for Llama 3 models, and so it had that information. So if you don't have the information, then you can append. So I've taken this entire article from Wikipedia and has fed it to the model, and then I basically asked the model to determine whether it makes sense. It's still hallucinated, so you have to still do some things there to make sure that the right data is fed. Our 70B model is able to give the best answer, which is Spain had won the World Cup. Now, I want to skip a few things. One concept which I want to explain, I won't run this in the interest of time. You can actually have PDF file or loads of PDF files. You can have tons of PDF files, thousands of PDF files, and you can actually store this in a vector database, which uses your transient database, and you can augment that information before it goes to the model. And here's a simple architecture for that. So user sends in a prompt. We are using a framework called LangChain. Now you can learn about this, but LangChain, what it essentially does is it allows you to to get data from external data and augment it in the LLM. And it provides libraries for you to do that. And I'll show you in the code in a bit. And this is your external data. So it pulls this external data. It can be Excel files, docs. It can be databases as well. It pulls this, appends it to your prompt, and then queries the Llama 3 model. Now, this is really powerful. The example I showed you, the Meta AI example on WhatsApp, Paris 2024, Llama doesn't have that knowledge, actually, about what is going to happen in 2024. It is able to call a search query on Google, get that results, append it to the prompt, and then send it to the model, and then model is able to intelligently infer from that information the response to the user, which is pretty powerful if you think about it. So here are the 3 steps. So I have this simple PDF file. It's a web page. I load it and then split the documents. The reason why you split it is when you load this document in a vector database, you have to then search these documents. And the search works slightly differently than our traditional RDBMS search. And so you split the document in chunks. And then you store it in a vector database, and then you can call and query against your document. So you can have a repository of documents, and you want to build a large language model running against that, you should be able to do that. Anyway, I'm not going to run through this because of the lack of time. This entire notebook which I'm showing is all publicly available, okay? So if you're running a team or you know somebody on your team who's an engineer, they should be able to get this from my GitHub account, and I'll share the link here. Now, prompt engineering, as you heard, has limitations. RAG has limitations as well. If you have large data set, you can't use it using RAG. You have to fine-tune your model. So let's say if Johnson & Johnson is doing a clinical trial, and they have 100 years of data, they can't really use RAG because it has limitations. So they would take that entire data set and fine-tune the model. Now that model is more intelligent towards all the healthcare-related queries. And you can also fine-tune it with a specific data set, smaller data sets as well. And there are different ways you do it using PEFT, which is parameter efficient fine-tuning, LoRa and QLoRa. And I would not go into details around that, but I just want you guys to know that this is another way to train your model for your own domain-specific purpose. And here's a simple architecture. You get your custom data set, take the foundational model, fine-tune it, and use RLHF, which is reinforcement learning using human feedback. Okay? I'll end with telling something about, so I want to show you Llama recipes. Now this is important. Again, we have, along with the models, we give a lot of tutorials, use cases, how to run prompt engineering, how to do fine tuning. All of that is on this website. If you search on Llama recipes, you'll be able to get all this information right here at your fingertips. And this is the power of open source. By open sourcing, we are enabling the community to come in, build this, and then every developer in the world who's thinking about building AI applications can benefit. Okay? There's a bunch of things here. We have built customer service chatbots using WhatsApp, Messenger, and all this code is right here. So you have an intelligent chatbot using Messenger, Facebook Messenger, or WhatsApp, which is right here. Okay, let me go back. So I want to end this talk with saying this very important message. These models are extremely, extremely powerful. And there are bad things which can happen with these models as well. So Meta has done taken a lot of effort in making sure these models are secure and safe for our users. We have done red teaming exercise with third-party vendors who are cyber attackers and who basically stress test our models against something which can be done bad. But it's important for you, if you're building a Gen AI application, to make sure your users are safe. And so we publish a responsible use guide, which has certain processes every Gen AI application developer should follow. There's active research going on in this space. You may be hearing in the news every week. There's a new model, new innovation which is happening. But the future is in AI. There is going to be tremendous innovation happening over the next several years. So, and we believe at Meta that the power is in open sourcing this, because you open source the foundational, and then people build innovation on top of that. Here are some of the resources. I'll go back to my deck. So this is the second last slide. We are working closely with Geo. As most of you guys know, Geo has 500 million users. They have different businesses, and they are using Llama to power their services. They have GeoMart, GeoFiber, GeoCinema. Every input request comes through a single customer service chatbot. It gets routed depending on the intent of that query to the right model, and then gets processed and served to the user. They're using prompt engineering, but that was not enough, so they did fine-tuning. We have a full use case published for this, so if you guys are interested, it has a lot of technical details around how they did it. And we are working with them on Llama 3 and other things as well. These are some of the resources, Llama recipes, which I showed. I also did a prompt engineering course with Andrew Ng. He's considered to be a father of AI. And you can take a QR code of this one if you're interested in learning more details around prompt engineering. What I showed today is like literally 1% of what I did in that course. And then here's my LinkedIn profile. If you feel like connecting, feel free to do that as well. All right. Thank you. I also want to thank a few people, Matt, who actually sat with me multiple sessions to curate this. Thank you, Matt.
Thank you so much. Thank you. Thank you.
And the entire TiEcon team for allowing me to present here. All right.